All right, we are jumping into MT5. This is lesson 5-1, page 1 of your notes. I hope you do have your notes out with you because these follow along directly with them. So we are going to be looking today at these goals. We're going to learn about the triangle angle sum theory and exterior angle theorem, and then some corollaries to the triangle angle sum theorem. Okay. So when we use this word, these terms, interior angle of a triangle, we're talking about any angle that is at a vertex of a triangle. So if we've got a triangle, an interior angle is going to be any angle that's inside at a vertex. So all of these are interior angles. So all three. Okay? So the triangle angle sum theorem describes the relationships among those three angles of any triangle. Okay? So the triangle angle sum theorem says that the sum of the measures of all of those interior angles is always 180 degrees. Always. You probably knew that. Just making sure we lock that in. 180 degrees every single time. Doesn't matter what that triangle looks like, always 180 degrees. Okay. So let's do this example. In your notes, there's a walkthrough where it's got 3 steps or 4 steps. You can go ahead and do that. You can even pause me, walk through and see if you can solve for angles 1, 2, and 3. Unpause me and find out if you did it right. All right. Now, did you find that the measure of angle 1 is 123 degrees? The measure of angle 2 is 52 degrees, and that the measure of angle 3 is 29 degrees? I hope so. Should have found that these 3 add to 180. So you can subtract those to find, or from 180 to find out that angle 2 is 52. Should have found that these 2 add to 180. So you could have subtracted 57 from 180 to find that 1 is 123. And you could have found that these 3 add to 180. And that's just one of the ways to solve it. You could also have found that these add to 180 and ignored these ones because that would make a whole big triangle in there then. Does that make sense? Just another way to do that. All right. Let's see. Go ahead and try that. Check your knowledge one on page 2. Pause me. See if you can solve for 1, 2, and 3. Okay. Now, did you recognize that angle 1 and 2 were vertical angles? And that vertical are always congruent? I hope so. You should have found that angle 1 and 2 are 63 degrees, and angle 3 was then 38 degrees. All right. There's going to be quite a few problems where you need to solve triangles in this unit. All right, let's go on to exterior angles of triangles. Now, exterior angle is when you've got your triangle and then you extend one of the lines of the triangle on, okay? So it's formed by one side of the triangle and an extension of that side. Okay, so in this example here, we've extended this side on and it makes an angle right here. That's your exterior angle. And you'll notice that it always makes a linear pair right there, okay? With one of the interior angles. It also then leaves 2 interior angles further away from that one exterior angle. We call those 2 interior angles that it doesn't touch remote interior angles, okay? So each exterior angle of a triangle has two remote interior angles that are not adjacent. Adjacent means not next to. Not next to the exterior angle. Okay? Okay. Now, why those are important, remote interior angles, is because of this next theorem. The exterior angle theorem says an exterior angle is equal to the sum of the measures of the two remote interior angles. Super cool, okay? So what that looks like here, if you look at this diagram, the measure of angle 1 is equal to the measure of angle A plus the measure of angle B. Okay? So for instance, if this was 40 degrees and this was 50 degrees, this one would be 90 degrees. Because 40 plus 50 is 90. Obviously, it's not 90 because it looks like more than 90, but that's how that works, okay? Okay, so let's see this proof that proves that this works, okay? If we're given triangle ABC, we're going to prove that the exterior angle theorem works. So given triangle ABC, we know that angle 1 and angle 2 equal 180 degrees because that's what the definition of a linear pair is. A linear pair make a line, and lines always equal 180 degrees. We also know that angle A, B, and angle 2 equal 180 degrees because of the triangle angle sum theorem. And because they both equal 180 degrees, we can set them equal to each other by substitution. Okay? And then we're going to get rid of those measure 2's by subtraction. And here it is. Measure of angle A plus the measure of angle B equals the measure of angle 1. We have proven that the two remote interior angles are equal to the exterior angle every single time. Every time. Super cool. So let's try it. So we need to find the measure of DAB in the front face of this building. So we are on page 3 of your notes there. If we zoom in and look at this, DAB is our remote exterior angle. I am going to redraw, let's see here, my triangle here. Okay, I've got D, A, B, and C. I've got 65 degrees down here. This is 6x minus 4, and this is 12x plus 7. All right. Here's our two remote interiors, and here's our exterior. So we're going to say that the remote exterior equals the two remote interiors added together. That's how that math works. So down below, you're going to fill in some blanks there that look like this. They did most of it for you. You're going to be filling in that 65. X will then equal 9 as we simplify down that problem. And they end up finding that DAB is 115 degrees when they plug X equals 9 back into DAB. All right. Now You go ahead and try this one. Find the measure of XYZ created by this triangle. Go ahead and pause me and take a try. Okay. Did you get that the measure of XYZ was 90 degrees? Hope so. All right. Now we're going to look at some corollaries. And corollaries are a theorem that follows as a direct result of another theorem. Okay? So because the triangle angle sum theorem, we have some direct, obvious things that we can know because of it. So the first one, pretty easy to figure out. Let's see. If we have a right triangle, okay, 90 degrees down here, and if all triangles add to 180, well, if there's 90 degrees down here in this corner right here, if that's 90 degrees, then these two must add to 180 minus 90, which is 90 degrees, right? Always. And we call that complementary. And so corollary 5.1 says that the acute angles of a right triangle are complementary. So the two small angles of a right triangle are always complementary. They always add to 90 degrees. Always. So that's kind of a hack for you. You don't have to do the add to 180. If you see it's a right triangle, you can just add those two small angles to 90. Okay, second one, corollary 5.2. There can be at most one right or obtuse angle in a triangle. Well, that makes sense as well because, well, if you have a right triangle, let's look at that. If this is 90, right there, can either one of these also be 90? No. Because then there would be, like if I made this one 90, this one would be 0 degrees. And that is impossible. Can't do it. Okay. And then let's do an obtuse. That's definitely obtuse. And let's make this 91 degrees. Can I make this one also 91? No. It's impossible. I can't make more than one obtuse angle in a triangle, because then it adds to more than 90 or 180 to greater than 180. There we go. Greater than 180. So it's not possible. Okay. Oh, excuse me, guys. 1 second. Let me go. Sorry. Sorry, I had to change colors on my 3D printer. All right. All right, so find the measures in the right triangles. And there's gonna be a lot of fill in the blanks in your notes here for this one. So let's look down at this first one. A for BCD. We're gonna be focusing over in here. It says, let's look at the fill in the blanks here. Because angle BDC and angle EDF form a linear pair, and angle EDF equals 90 degrees. Oh, I'm trying to erase. Equals 90 degrees. By the supplement theory, measure BDC equals 90 degrees by the supplement theorem. Therefore, the measure of BCD plus the measure of DBC equals 90 degrees because the acute angles of a right triangle are complementary. Okay, what did they actually just say? Let's go look down here. Okay, they said that because this angle and this angle form a linear pair, they are both 90. okay? Because they both have to add to 180. And if this one's 90, this one's 90, right? Which makes this guy over here a right triangle, which means that these two acute angles over here must be complementary, which means we can add these two together to equal 90, which is what we're going to do on the next screen. Okay, so we're going to set them equal to 90, solve, 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 and get that x equals 28. Then we're going to plug that back in and find out that it's actually 54. Yay. Good. Okay. Let's go to the next one. Now VAF. Because the acute angles of a right triangle are complementary, measures of VAF and AFB equals 90 degrees. Okay, so this one also tells us that because this is a right triangle, then this angle and this angle are acute. They must be also complementary and equal to 90. So we can set them equal to 90 over here, which is what they're going to do. And they put that into your equation there. This is what you're going to fill in. 60 equals y. And they're going to plug in the 60 and find that that equals 30. Right. Now, then they ask if we've got enough information to solve for FED. I would suggest that you go ahead and try that on your own. I bet you do. Okay, now go ahead and try this. Solve for all of the angles in here. Pause me, come back and check it. All right, did you get all of these angles? All right, check with your teacher if you got stuck on any of these. And then go to your ALEKS topics. See you later. Bye.